going to solve question number 4 in tutorial number 7, which where we've been given a cylindrical drum which is rotating about its axis and having this information. So the information that we have under this question is the mass is 1.5 kg, L, which is the length, is 2.858 meters. Then the torque, 9.8 newton meter. The initial angular speed, 8 radians per second. Final angular speed, 30 radians per second. And the angular displacement is 50 radians. So the question says, show that R is equal to this, and then we're told also to find R. So it is so much important that we know what we are talking about. In the question, we are told to say it is a cylindrical drum. So maybe let me just try to illustrate a little bit here for something like this. So we have something like this, where we have this as the radius, and we have this, which is L. Now, the moment of inertia for this, is mr squared over 4 plus ml squared over 12. So this is the moment of inertia for a cylindrical drum. And this one, we know that torque, we have the aspect of torque here. We know that torque is equal to I alpha. This is moment of inertia, and this is the angular acceleration, and this is the torque. So we can, so from this point, we can even divide by alpha, and we're going to have, so if we divide by alpha, also here by alpha, we're going to get I will be this one over alpha. So let us say this one is equal to torque over alpha. Let us call this as equation 1. So let me just erase this part. So if this is equation number 2, we can equate the two equations. Our target is to show that this is equal to this. So we are going to make sure that we come up with the expression where we're going to remain with R here. So here, if this one comes on the other side, we're going to have minus ml squared. So since we want to remain with R, we can multiply by 4 over m, even here by 4 over m, so that this and this will go, this and this will go, and this one. So from this point, m and m will go, and 4 into 4 is 1, 4 into 12 is 3. So here we're going to have 4 torque over m alpha minus L squared over 3. This should give us R squared. So from this point, if we introduce the square root to both sides, this one and also this one, we are going to have R. But we know that angular speed squared is equal to initial angular speed squared plus 2 alpha, then angular displacement. So from this equation, to say v squared is equal to u squared plus 2ax. Now in rotational motion, we use this one. So from this point, we want to make this the subject. So we have angular speed squared minus, when it crosses the equal sign, this squared is equal to 2 alpha theta, divided through by 2 theta, also here by 2 theta. We're going to have this and this will go, this and this will go. Alpha will be. So putting this into this, we have R will give us. So if we multiply this just on this part by 2 theta, the denominator and numerator will have 2 theta times 2 theta, so that we just Okay, so this and this will go. And what we're going to have is the square root of 4 times 2, it is 8, then 8 theta, then dot over R can also be expressed in this form where we have 8 theta top everything raising to the power half. This one and this one, it is one and the same thing. So this is how, or this is the needed expression for the first part. Now, for the second part, R, it is just a matter of putting in the values where we have 8, the theta that we have is 15, the top is 9 over mass 1.5, final angular velocity, that is squared minus initial 5 squared, minus L 2.858 squared over 3. So if we evaluate this, we are going to have square root of 0.169. Punching this on a calculator, we are going to have 0.13 meters. If we convert to centimeters, we are going to get 13 centimeters. And this is the value for R. Thank you so much for watching the video.